This is section 7.1, moving into geometry and trigonometry. We're looking at angle relationships in triangles. The triangle is the simplest type of polygon. The structures of buildings and machines often contain triangles. Triangle shapes can be particularly strong and rigid since the shape of a triangle cannot change unless the length of a side changes. In this section you will learn about some of the other properties of triangles. So polygon is the first definition. Lots of definitions here, by the way. I'm going to cover all these today. First one is polygon. It's a closed figure made up of line segments. So any of these are considered polygons. Okay?
Isn't it any shape?
Yeah, as long as it's closed in, right?
Circle's closed.
With straight lines.
It says segments. That means there's more than one. So
Yeah.
Circle, polygon.
Yeah, line segments. So circle wouldn't be considered a polygon, no. So it has to be straight line segments. So like a square, triangle, octagon, pentagon, hectagon, decagon, right? 10 sides. Yeah.
Would a dome be a line segment?
No. No. No curved lines. We're talking about straight line segments. Okay? Okay, a vertex is a point where two or more sides meet. So it's a point, a triangle therefore would have three vertexes, or they call them vertices in plural. 1, 2, 3. A square would have 4. Rectangle would also have 4. So it's where two line segments meet. That's called a vertex. An interior angle is an angle formed on the inside of a polygon by two sides meeting at a vertex. So a interior angle is always the inside angle where two sides meet. Okay? These are all interior angles. An exterior angle is an angle formed on the outside of a geometric shape by extending one of the sides past a vertex. So, if we had, yeah, too low? Thanks. If we had a shape like this, our standard stop sign or octagon, right? 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. An interior angle is any of these angles between two sides on the inside of the shape. An exterior angle is not this angle, is not between two sides like this. Okay, it's not this. What it is in fact is if you take one side and you extend it, it's that angle. Okay, so you can take either side, that side or that side, and extend it, it's that angle. Alright, so an exterior angle, you take one side, so dealing with a square, extend it, it's this angle. That's an exterior angle. Alright, take a triangle, one side, extend it, it's this angle. Any questions? Alright, so those are our definitions. We do a couple of proofs here for interior and exterior angles. So we draw a large triangle. We all don't have protractors, but we can go over this very quickly. Label the first vertex A and the second B. So here's our triangle. Measure each of the interior angles from your triangle with a protractor. Mark these measurements on your diagram. So if you measure the interior angles, it would be these angles here. Okay? Anybody know what we know about interior angles? Already people have their hands up. Alvin.
They always go up to 180.
Good. So the sum of all interior angles and he said equals 180. Is that correct?
180 degrees.
Yeah, there's a part of this that's missing though. There's 180. Sum of all interior angles. Yeah, AJ?
Of a triangle.
Good, of a triangle. That's important. Because we know for a square it's what, right?
360.
Right, so it's 360 for a square. There's actually a pattern to this. Does anyone know the pattern? Yeah, I don't know.
N minus 2 times 180.
N-
And the number of sides.
Good, n minus 2 times 180. Right, n. So the interior angles add up to n minus 2 times 180. So if we deal with a triangle, we can see here that number of sides of a triangle are 3 minus 2 is 1 times 180 is 180. Number of sides of a square, 4 minus 2 times 180, 360. Okay, so the pattern works. AJ.
Is x a variable or multiplication?
Where? Here?
Yeah.
Multiplication.
Oh,
So maybe better like this.
sure.
More clear? Okay. Good, very good. You guys are ahead of the game. You guys learned all that in grade 8? Some of you? You learned the 180 thing?
Yeah.
Okay, all right. Each vertex extend one side of a triangle to form an exterior angle. Measure each of these angles and mark the measurements on your diagram. So if we measured this angle, and this angle now. Find the sum of the exterior angles. Compare the sum you found to those calculated by your classmates. Tyler, yes.
The exterior angle should equal 360.
Yes, do you agree with that, Tim?
Oh, 360 degrees of a triangle.
For a triangle, it should be 360. Who agrees?
Assume 360.
No.
Alex?
No, I don't know actually.
It's on the book. It's for exterior angles.
Yeah.
For square.
Oh, never mind.
So it should be the same as for interior angles, right? Because each angle here, each line here is going to be 180. Right? This is going to be 180 here. So if these three angles have to equal 180, and each one of these angles is 180 minus the interior angle, each of the exterior angles will also add up to 180. Okay?
We did this wrong.
Find the sum of the exterior angles, compare your sum you found. Reflect. Do you think the sum of the exterior angles is the same for every triangle? What do you think? Adam?
No.
Why not?
Because a equilateral triangle will have 90 degrees, will have 180 on each of the outside angles. Sorry, 120, not 180.
Good. So this is an equilateral triangle.
Equals 360.
Yeah, sorry. So that first part that I said is wrong. Sorry. All exterior angles don't add up to 180. My mistake. 360. Tyler was right. Tyler was right. My bad. My mistake. Here we see it with an equilateral triangle. Let's check it with a 90-degree triangle as well here. So we can say this is 90, 45, 45. So this would be 135. This would be 135. And this would be 90. So that's 270 plus 90, 360. Good. So all exterior angles, in fact, add up to 360. Thank you, Tyler.
Welcome, sir.
Describe the relationship between the exterior angle at a vertex of a triangle and the interior angles at the other two vertices. All right, so here's an interesting one. So this one I'm quite sure of. So this angle, let's call it A. How does angle A relate to angles B and C? Exterior angle at a vertex of a triangle and the interior of the other two vertices. So here's the two vertices, 1, 2, 3. Here are the two interior angles, and here's the exterior angle. How do they relate? Yeah, Justin.
A equals B plus C.
Good, A equals B plus C. And how do we know that? Because, again, all interior angles of a triangle add up to 180. Also, the exterior angle, right? Any exterior angle is extending one of the sides is also 180. Okay? So that's why angle A is 180 minus this angle in here. Let's call it X. Right? 180 minus X is A. And same thing for the interior angles, is 180 minus B and C is going to be A. Does that make sense? A little bit confusing, but the exterior angle of one vertices is equal to the two interior angles of the other two vertices in a triangle. Okay? There's the reasoning. There's the 180 line, and all three angles also add up to 180. Right? So if we did this, X plus B plus C is equal to 180. Right? X is equal to 180 minus B minus C. And then A is equal to 180 minus X. And now if I substitute X in for X here, I get A is equal to 180 minus 180 minus B minus C. These cancel, and I'm left with A is equal to B plus C. Does that make sense? Here's the algebra behind it, okay? All right. Okay, we're going to go to the first example. We may come back and get a class set of laptops to do the sketch pad if we have time. But for now, we're going to go to the first example. Find the measures of the exterior angles of triangle ABC. ABC. So the exterior angles. So let's first deal with the exterior angle D. We're missing an interior angle. We should get this angle first. Yeah, Christian in the back.
Well, so what you do is to solve for example C, it'd be 180 minus 50 minus 85. And that would equal 45, yeah.
45?
Yeah.
You sure?
Sure. Yes.
95, yeah, 45. Okay, so this angle is 45. Now we can find any exterior angle, right? Pretty easy. So this is, let's say, exterior angle. We'll call it angle. And the way the nomenclature works here, guys, is that you follow the letters. Okay, so the middle angle is the actual vertices. Sorry, the middle letter is the vertex, the vertex. And the other two letters show you kind of the way you're going. So you would follow this DAB, you would go from D to A to B. Okay? So that's how these angles work. The reason why is we don't just say angle A here, is because angle A could either be BAF or it could be DAB. Does everyone understand that? That's why we use the three letters to represent the angle. Because it could be kind of two, it could either be the exterior or the interior. The letters show you the direction that it goes, and the middle one that's trapping it, that's the angle. Max.
So if we were labeling it, would DAC be 180?
DAC? Yes. Be very strange to call that out, but yeah, you're right. Yeah. Any other questions about that? So let's get all of these exterior angles here. I'm going to name them. So we'll say angle BAD. Bad. Okay? BAD. I could have also called this angle DAB. It would have been the same thing, but bad sounds cooler.
Yeah.
So angle bad is equal to what? Matthew, Vidali.
95? I mean 85?
How'd you get it?
I substituted,
You said 85?
well, 95.
Okay, yeah. How?
Because everything inside of the interior angles of a triangle have to be equal to 180.
Yeah, you just added these two up, right? The sum of the interior angles opposite that angle, right? I hope that's what you did, right? So it's just
Minus 85.
50 plus 45.
Minus 84.
Yeah?
Could you just subtract 180 or 85 from 180?
Yes.
It's so
Yeah, you could have done it either way.
That's my way.
Yep.
So when
You have to give a name to that new angle we're subtracting 180 by. 'Cause, like in the solution they give angle CAB. So would we have to name
C-
That's the 85.
That's 85.
Fine.
Yeah, so there's two ways we could have done this. One, we could have done the sum of the opposite interior angles, or we could have just done 180 minus 85, which yeah, is easier. 180 minus 50, 135. This one, 180 minus 45 would have been 95. No, sorry. 135. My bad.
So it doesn't use 140. No, it's 140. No, sorry, 130.
Thank you. Any questions? Example 2. What is the measure of each exterior angle of an equilateral triangle? So equilateral, we know all angles are the same because they're equilateral. They have to be 60 because three angles have to add up to 180. The measure of each exterior angle, you're going to take 180, you're going to minus 60. So each of these are going to be what? Right, 120. Equilateral, all having all angles equal. Any questions about that one? All right, finally, key concepts. The sum of the exterior angles of a triangle is 360. Thank you, Tyler.
Yes, I'm in a video.
There you are, forever commemorated. The exterior angle at each vertex of a triangle is equal to the sum of the interior angles at the two other vertices. Okay? It's also equal to 180 minus its vertice, interior angle, right? Its interior angle. Okay, any questions? All right, that's it.